Laura, it's Melissa. I think we're going to go ahead and get started. Can you hear me okay?
Yep, hear you great.
Okay, great. Thanks again, everyone, and welcome to our final webinar in our Integrated Water Management webinar series. My name is Melissa Soline. I'm a program manager with the Great Lakes and St. Lawrence Cities Initiative. For those of us that aren't familiar with the organization, we're a coalition of over 115 U.S. and Canadian mayors working to advance the protection and restoration of the Great Lakes and St. Lawrence River. I have joining me from the Cities Initiative, Laura from our Chicago office, as well as Simon. They're going to be helping us out from the technical perspective with the webinar today. Before we get to the meat of the webinar, I'd just like to run through a few logistical items. First, if you are signed into the webinar correctly, you should see our agenda up in the middle of your screen. And then to the right, you'll have a dashboard that will allow you to type a question or a comment in the chat box. There's also a hand icon that you can click that raises your hand and gets our attention if you, during the question and answer period, if you want your line unmuted to ask a question, you'd use that icon. If you have any technical issues during the webinar, please feel free to email me. My email address is at the bottom of the agenda up on the screen right now. Feel free to jot that down so you've got it with you throughout the webinar and get in touch if something comes up. All participants are going to be muted during the presentation portion of the webinar. Again, we will have a question and answer session at the end. And if you do have a question, as I mentioned, feel free to type it in the chat box at any point during the webinar. You can do that, and we'll be collecting those and reading them back during the question and answer period. Alternatively, you can raise your hand, and during the Q&A, Laura can unmute your line and you can ask your question. We are recording the webinar today, so it'll be archived on our website in a few days. And then finally, at the end of the webinar, we just ask that you stay on for a minute or two to answer a few polling questions that we're going to run through. This will help us develop better webinars in the future and get some feedback specifically on the content that we'll be discussing today. So again, welcome to Advancing Integrated Water Management, the last of our Integrated Water Management webinar series. I've had the privilege of working with the Great Lakes Commission, Environmental Consulting and Technology, and the Alliance for Water Efficiency, as well as countless others on the Greater Lakes Reconnecting the Great Lakes Water Cycle project. This project is an effort to quantify the economic and environmental benefits of green infrastructure and water conservation for municipalities. This webinar series grew out of the project as we began to realize there was a need to promote discussion on the issue of integrated water management among and within municipalities. John Jackson, the project manager, is going to get into more detail on that. So I'll just end by giving you all a quick preview of our webinar today. We'll be hearing about the major lessons learned and takeaways from the Greater Lakes project from John, the project manager. We'll also hear from Jim Ridgway of ECT on a few tools that ECT developed to help a municipality evaluate green infrastructure. And we'll hear from Becky Pearson from the Great Lakes Commission on a guide to help start the integrated water management discussion within a municipality. So without further ado, I'll hand things over to John to get started on lessons learned and takeaways from the project. John, the floor is yours.
Okay, thank you, Melissa. Just let me make sure I've got my screen here. Okay, that looks right. Am I correct?
Yep.
Okay, everybody else is on mute. That's what's throwing me off. Okay, I'm John Jackson, and we've been working on this project for, we're going into ending the third year of it, and our partners on this have been the Great Lakes Commission is our home base for it, a binational organization, and this is a binational project. We've had a consulting team, ECT, Environmental Consulting and Technology, working with us, and you'll be hearing from Jim about some of that work, and also the Alliance for Water Efficiency, which is a not-for-profit group, and I'll be talking a little bit about the tool that we've used of theirs that's been very valuable and we think be valuable for the rest of you. Another partner, of course, is the Great Lakes and St. Lawrence Cities Initiative, which has really played a very helpful role in helping us, first of all, reach out to municipalities, but secondly, to make sure that what we're doing is really as relevant as possible for municipalities, because this project is really being done to help out municipalities. And of course, finally, we have to thank our funder, the Great Lakes Protection Fund, who has been very generous to us in helping us get this project going. The problem that we're addressing in this project is to how that we've fractured our water systems. We've disrupted the natural water flows. And the natural water system in general, of course, all these things are general, is that when there's a rainfall or when there's a snow melt, about 20% of that water flows off quickly and immediately in a natural situation with natural ground cover, flows off very quickly into the nearby streams, rivers, or lakes. And about 50%, about half, goes into the ground, infiltrates into the ground to restore the groundwater supply, which is so important for our uses as well as for natural habitat, for wetlands, etc. Unfortunately, as we've developed our municipalities, we've changed a lot of that natural surface into very impervious cover. About 30 to 50% in most municipalities in the urban areas. These are things like roads, runoff from roofs, parking lots, and even lawns that often are compacted. They're not totally impervious, but are less pervious than they would have been before. The result of that, the impervious cover, is that instead of 10% in the natural system, we get 30% runoff when there's a rainfall or a snowmelt very quickly and immediately. And generally what we do in our municipalities is rush that, direct that into a pipe so that it's carried off quickly from the roads, etc., into nearby streams, rivers, or lakes. The impact of that is that we have less water going into the groundwater. That's one of the impacts. And then we have the natural system. So we're not naturally restoring the groundwater supplies to the same extent, which is critical for both human and wildlife needs and the general habitat. In addition, because we're getting this quick rush of outflow of water during storms, and we're seeing more of this as we're going through climate change things, the flash floods, that the piping systems get overwhelmed and can't handle it. We get back up with flooding of roads. We get back up into people's basements, which is an incredible headache for everyone, and including municipalities. And also at the point where the water does rush out into a stream or whatever, we get major erosion problems because of the speed and the amount of water that is going out. So in this project, we're trying to find ways to reconnect the water cycle, as we say, and we are talking on the basis that we have to be looking at water supply, what we do with wastewater, and what we do with stormwater as all part of one integrated cycle. And you'll hear Becky talk later about the silos. We tend not to look at these and plan for the three of them jointly as part of the same system, because they affect each other and the solutions work with each other. Here's a chart which I won't go through in great detail, but showing again the potable water, that's our drinking water, wastewater, stormwater, and the parts that we're focusing on are what you see in the sort of not the mid-blue color, where it says demand management, for example, which is things like water efficiency, gray water, which is reuse of water, recycling, the stormwater reuse, etc. So that's where we really have been focusing our work. So I want to just tell you a few of the main lessons that we've learned out of this that have really become our guiding principles as we do our work. The first one is that we need to set up strong source water protection programs to protect the waters on a watershed basis for both natural and human purposes. We also need to engage in water efficiency and conservation programs to reduce the removal of water for human consumption from groundwater or from the lakes or the rivers. We need to set up wastewater reuse systems to further reduce water consumption. So instead of just using water once and then throwing it away, we reuse that water by using it to use for outside watering, for example, or to to deal with the flushing toilets as another example. We are using heavily treated water, drinking water, quality water. We should only be using that for things that need that level of purity of water. And that means, for example, that we shouldn't be using potable water for most outdoor uses or for things like flushing toilets or washing clothes. And we need to redesign our urban areas to reduce the use of impervious surfaces to allow for more infiltration where the water falls. We need to also make sure that we treat green and gray infrastructure as part of one system. And you'll hear detail about this from Jim, so I won't go further into it. And we also need to look at stormwater and say, can we capture part of this stormwater to use to help reduce our need and be part of our water supply? So by having cisterns, rain barrels, etc., to use for both indoor and outdoor use. Now the good news is that there's a lot of this going on, and I'm sure the municipalities who are on this call and citizens groups who are on this call, for example, many of them are working on really doing these sorts of things. But what we find missing and what we feel is the next step we have to have is to have a more systematic approach to it. And we have to have more state and provincial requirements for using these sorts of things as well as funding for using these sorts of things. But it has to become more of a systematic thing. This particular session is focused on tools. And one of the tools that we used in this project, we worked in 6 municipalities, 3 in Michigan and 3 in Ontario. The 3 Ontario ones were in the Grand River watershed. The 3 Michigan ones were in Oakland County, which is right near Detroit. But here we had the work of the Alliance for Water Efficiency to help us figure out the best ways in which to use water efficiency, water conservation programs, and their analyses. This tool, if you want to get access to it, you need to get in touch with the Alliance for Water Efficiency, and you see their website there, and you see Bill's email address, very helpful, and need to actually join their organization to do that. But we found it incredibly useful. To just give you a sense of some of what you get out of it, is that they put in a lot of inputs, a lot of detailed inputs. I'll just highlight a couple of them. The water demand forecast, avoided utility costs. So if you don't use as much water, what does that mean in terms of the cost of constructing your system? And energy data, which is very interesting in terms of if you're not having to pump as much water, what's the savings from that? And then they show outputs, which are how much less water you use, what are the costs and benefits of that, what impact does it have for a municipality in terms of the revenue that they raise by selling water, and what impact does it have on greenhouse gases and on energy reduction. And it also what's really important, and they show in their tool, is both short-term and long-term impacts. Short-term would be things like water purchasing costs if you're buying from a wholesaler, variable water treatment costs, the energy costs, of course, related to pumping, and the chemical costs. And the long-term cost is avoiding, deferring, or actually being able to stop expansion plans. I live in the region of Waterloo, and here they had figured they were going to have to build a pipeline out to Lake Erie for, it's about 70 kilometers. And they have, because of their water efficiency programs, now been able to take that out of their plans and said, we don't think we're ever going to need that. That is saving them $1 billion in terms of construction costs. These are sort of tables that come out, and I'm not going to go through these, but it's just to give you a sense of very detailed information according to each type of activity. Here's the one for Oakland County. Each municipality is quite different in terms of what comes out. And you get charts such as this, and this is Oakland County showing when the water is used. And you find, for example, the one at the back, which is Commerce Township, the heavy water usage is in the summer. And therefore that directs you to where you need to put your focus. Clearly it's outdoor summer use. That's the big issue in Commerce County. So I'll leave it at that point. I just wanted to make you aware of that tool. And as I said, get in touch with the Alliance for Water Efficiency for it. And we'll turn it over now to Jim to talk about the tool that has been developed specifically for our project and which will be available on our website.
Hello, I am Jim Ridgway, and I work for Environmental Consulting and Technology, and we were tasked with, just as the Alliance for Water Efficiency was looking for the least cost ways of managing water, the drinking water half, we were tasked with identifying cost-efficient ways of managing stormwater and related subjects. And as such, we've generated a tool. This talk will talk a little bit about the tool and specifically talk about a kind of a little spreadsheet model that helps, that's different than some things in the market, but similar in other ways. This is the identical thing that John showed before, and I think it's important when we start to just remind folks that our general public is generally very comfortable paying for water if they have a water supply. They are relatively comfortable with paying for wastewater and wastewater treatment. But how we pay for stormwater varies from county to county, city to city, state to state, and is something that we're working on. So as the public works community is grappling with how better to manage stormwater, one of the first rules is get rid of some of the concepts that we developed in the 60s, which was take all the water you have and run it downstream and worry only about flooding. So as you start managing stormwater, some of those areas in the medium blue where it says reduce sewer overflows, and these are benefits that may or may not be paid for by other entities than your drainage entity. And when we talk about silos a little later, I mean, that's really the challenge. You can get a benefit that will improve both stormwater management and wastewater, or both stormwater management and drinking water source, but how you pay for it remains a challenge with the current silos we have in place. The question most people ask is green infrastructure cheaper? I would say yes in almost every case. But if you were to look at the case studies that were assembled by the American Society of Landscape Architects at the request of the EPA, they find some things a little bit different. Yes, the majority of them think it reduced costs or did not influence costs, but some would say some of the projects actually increase costs. As we move further in this discussion, you will see that some part of that is because maybe the green infrastructure chosen was not the one that should have been applied. And that will become a little bit more clear as I move forward. However, when evaluating green infrastructure, we evaluate gray infrastructure if there is no flooding, no standing water, particularly in stormwater. Yet we evaluate green infrastructure to a higher standard. We want to increase infiltration. We want to reduce nutrient loadings. We want lower cost. So when comparing green infrastructure to gray infrastructure, there are benefits of green infrastructure like greenhouse gases, energy savings, less sewage control, but those benefits are often not realized by the public works officials. So one of the things that we are trying to do is first remind the public works official, prioritize what you're trying to do with green infrastructure. So, you know, one of the first things that makes a lot of sense is try to increase infiltration, and that can be done both on public properties or on private properties. And how you get folks to do that, either incentivize or requiring them to do things, depends on a number of things. But in almost all cases, increasing infiltration is good. And then where you storing water is also very good, and how you do that is varies from place to place. And when property is very, very small, you can do what are apparently more expensive treatments, like the one shown on the left, which can store quite a bit of water before it overflows to the storm drain, but it is costly construction where land is at a premium. On the right was almost the opposite. This was a road reconstruction that they actually took 2 lanes of traffic out, which opened up the space. And this was a road that had been over-designed in the past, and by taking 2 lanes of traffic out and storing water, it was a least cost method of addressing some stormwater issues. And it encouraged infiltration. And storing water for other uses. On the left, this is a little community garden where they've connected all the garages almost in the neighborhood to this series of barrels, and they didn't want to pay for water, and this is the way they did it. On a much larger scale, on the right is actually a Target store. They are placed on top of a capped landfill, so how they infiltrate water and how they manage water is very, very difficult and sophisticated. But in their case, they store water in the cistern, and they use it to water the plants and around the building. So in most cases, volume is the driving force. If you look at the CSO controls or the sanitary sewer overflow controls or flooding prevention, the first thing you got to do is get your arms around volume. And this is some work that was done in Milwaukee, where they took an awful lot of data, and they just tried to show what the cost of managing different types of best management practices worked on a dollars per gallon managed. I want to add one caveat. You're going to see some slides later in the project that look like these slides, but they are actually measuring different things. They are apples and oranges. Do not look at 0.27 and wonder why it's different in the future. I can explain it, but not in 20 minutes. In other areas of driving force, and a lot of times that's just built into either rules or guidance, and in this, once again, is that same study, and in this case they were looking at how the cost was on area managed. A green roof, they would only manage the area of the roof, where a rain garden could manage a larger volume. And to give you some idea, comparing these costs on the area basis to what the area would be if they did a deep tunnel storage for the same volume, you can see that if you tried to solve the entire problem of green roofs, it'd be more expensive. But if you try to solve the entire problem with a mixture of green infrastructure, it is less costly than the gray infrastructure solution. This is from the same study, and it provides a little bit of detail. If you look at the top line, green roofs, it's the cost per square foot, but a green roof only manages a square foot on the green roof, where rain garden, if you go to the second column, they assume that 12 additional square feet could be managed by a square foot of rain garden, and similarly down there, and that's where you can get the dollars per square foot managed. I am really in the weeds, and I apologize for it, but it's my way of saying what we are charged with doing is finding how to take a large group of small projects and manage it in the least costly way so that it is, in fact, less costly than gray infrastructure. This is a study that was done on the West Coast, and it took similar information as those previous slides, but then laid it out. In their case, their least cost solution was downspout disconnections. And if it was less than $1 per gallon managed. But at some point they ran out of downspouts that could be disconnected. And their target for CSO control was in excess of 35 million gallons that they had to capture and manage. So the next least cost was go to the schools and disconnect them. And you can see the incremental additional volume, the incremental additional cost. The next least cost was church disconnection. They went to churches, had an incentive program, and that could work. The next one, sewer separation, is actually a gray infrastructure solution. But if you could get some of the water out of the combined area taken to the river, that was better for CSO control. And then the next volume was curb extension. So as you can see, by capturing a number of technical BMPs, you could get to the volume that needed to be removed. So once again, what are the technical drivers? We start with volume management. But in some areas, and particularly if it's a combined sewer overflow challenge, sanitary sewer overflow challenge, flooding challenge, volume must be managed. And in fact, volume must be managed in all of these cases. You could be being driven by a nutrient loading on a TMDL, but if you're causing additional flooding, no one is going to build it. So, you know, the first word in all of this is you must manage flooding. But there are going to be some areas where for example, the nutrient loadings downstream are an issue, and whether it is an incentive program to reduce those or if there's a regulatory program to reduce those, certain BMPs work better for removing pollutants than others, and we are well served to select BMPs to address those matters. And most public works folks also are interested in green space and quality of life, but sort of down the road, down the priority plan. So we were asked to put together a impact tool, and Water Resources Impact Tool. It includes a number of things, some of which are managed by some of the spreadsheet tools we're going to talk about, and some of which that are not. But specifically, we looked at all of the spreadsheets tools, or just BMP evaluation tools that were out there. And there are a lot of them, and a lot of them are excellent. As part of this report, we will have a summary of all of the ones that have been put together by WEF and WERF and ASCE, and there are a lot of tools. And they answer a lot of the questions, and they're great for either big picture views of this and or designs for site-specific stuff. But one of the things that we were not able to find is how a public works person or a city could get their arms around lowering the cost for a green infrastructure program. How do you compare how that mix is going to go together? So this is what the tool, one of the spreadsheet tools, will look like. And later you will see these same numbers in a product that was done for the city of Guelph. But this is, first let me just talk about the tool. If you're online on this tool and you hovered your little cursor over that little red dot, it would tell you which each of these variables are. And so it can give you instructions, it can talk about what options there are for different inputs, and then it basically does all the number crunching. This is not a highly sophisticated volume model, but it's one that's used all the time, and it's good enough, in my mind, to get your arms around this problem. So I'm about to click the next one, and it's going to change this half-inch rain to 2-inch rain. And if you look at the right column, you'll notice, what a surprise, you get a bigger rain, you have more volume. It's not directly linear, but some change different than others. But more importantly, you recognize there's a couple of things on this particular site that generate a great deal of volume, and we should probably pay attention to those great deals of volume. So then, on each of the specific little areas, you can decide what BMPs work, how big they are, just how much water they serve, because the very first thing you're trying to do is get your arms around the volume that is managed. Once again, this tool helps you walk through things, how to change variables and how the numbers change. So we took this tool and we applied it a couple places, but including at Guelph. And the Public Works folks at Guelph needed to communicate with their elected officials on how the green infrastructure program could be incorporated, and just help them get around what it might look like and what it might cost. So they had done some planning on a park area. They had several options. There was one that was preferred by the public, and we were charged with just getting our arms around the least cost way of controlling the stormwater off this entire site. I like talking about parks because often public works types look at public land, much of which is parks, and say, oh, well, we can go store water there. I happen to be from a community that recently had a parks millage, and the soccer moms wanted more soccer fields, and the baseball dads wanted more baseball fields, and the last thing, and there's very little property around, the last thing any of them wanted was a wetlands that was going to prevent either one of those. So even though parks are open, and even though parks are public, managing the green infrastructure on that park has to be done such that the use of the park remains, and it's something that folks want to live and play around. These are basically, we looked at the types of green infrastructures that could be used on this park, and we calculated how much volume you could capture in a 100 square feet of area, because you're trying to shoehorn this work into an existing park. The spreadsheet, on the left are the little parcels of land within the park. Some assumptions go across, and there was a proposed rec center that was going to go in, and if they put it in, they could expect to add another 11,000 cubic feet of water that had to be managed if they wanted to capture the 1-inch storm, which was the design criterion selected for this exercise. In other areas, like the existing drive, we had already calculated the volume that needed to be captured from the existing drive, and there are a couple ways you could have captured, managed it. You could have bioinfiltrated it next to it. You could use porous concrete, pervious pavers, or some underground storage, and the size of those would vary to capture the amount that was a design storm, and therefore the cost of those would vary. And so by the time you get over to the construction cost, you look at these and you think, oh, underground storage was the least cost. I'm not suggesting that that's always the least cost or the only solution. I'm just saying that the public works person could take a look at this and think, I know what that looks like, I know what it costs, and by adding all the costs for these different things, you could come up with what the total cost for the park would be to capture the design storm. And not surprisingly, some were quite expensive and some were less expensive. But by mixing it all up, the overall cost was, some would argue, reasonable. And that's the sort of thing that a city council wants to know if they are choosing to proceed. And once again, this is what was shown. There's areas that we would have proposed green roofs and some pervious pavement and certain little swales that were shoehorned in around the active recreation sites. I think a workable plan, and a plan that could be easily viewed by a public, presented by a public works official to their commissions, and they would understand what you're trying to get done. We also were asked to look at a road, and roads are a challenge. They make an awful lot of stormwater, and they are giant gray infrastructure stormwater management system. And so to green them is a challenge. And so we were asked to look at Stevenson Road. And this is a similar sort of thing. On a given road, we could look at bioinfiltration or pervious concrete, pavers, or underground storage. We knew what the design storm would be, what the size of that would be, and what the relative construction cost would be. And using that similar assumptions, if you look starting at the left, you can see a portion of the road could have been stored on this park, and the highlighted yellow area is the physical area that would be needed to be shoehorned into that park to capture the stormwater that's over, basically to the left of this. I'm not saying that the parks people would agree with it, but it allows you to see just about how much area would be required. The area in between with the yellow hashing was an area where pervious pavement was suggested because there wasn't sufficient property to handle the volume of water that you're trying to capture. And the rights of way were quite narrow here. The road then goes up on Casino, and there's a little area, and you can see the little dot in this relatively large plot of land. That was relatively easy to manage. And then on the right-hand side, you can see the little park with where the yellow box is bigger than the park. And what that tells you is you don't, even if you took the entire, small park and used it as a bioinfiltration area, you don't have enough space. In both the areas on the right, where the wide area on the left is pervious pavement across the entire street, the one on the right just has a parking lane of pervious pavement because that was enough to manage the volume we wanted. I stole this from somebody else, but it really talks about the little things a community can do to manage stormwater. First of all, make sure, I start with one, code it. Make sure that your existing codes, first and foremost, don't preclude green infrastructure and hopefully encourage green infrastructure. Putting that into your building codes helps. Retrofitting things, there are ways that you can incentivize owners to retrofit. In the earlier presentations that were done by the Alliance for Water Efficiency, they showed that in some areas, if you replaced shower heads, it was cheaper for the utility than if you didn't. There are plenty of places that retrofitting property is cheaper than doing gray infrastructure. Bringing it to scale is a whole other challenge. We can talk a long time about it, but how you pay for it and how you build a bunch of little things and manage a bunch of little things is a challenge, but doable, and it's being addressed in many areas today. The incentive, how you build your stormwater fees and the incentives you bake into those are probably, in my mind, the biggest driver for getting green infrastructure put in place rapidly, particularly on private property. We need to in areas where there's tight development, there has to be a way that you either use a bank or some kind of off-site systems for paying for green infrastructure. The best example of that is in Washington, D.C. Obviously, if you need to capture stormwater in downtown Washington, D.C., there is no property, and that property is really, really expensive. So there's got to be a means of causing a developer to take responsibility for their stormwater, but not necessarily on the property they have. If you do green infrastructure right, you can offset future gray infrastructure costs. And the example that John spoke of earlier about the avoided cost up in his neck of the woods is a good example, even though that happened to be about drinking water. Coordinating among folks. In a minute, you're going to hear from other folks on silos and why it's hard. That is also a big issue. And trying to expand it beyond city limits is good because sometimes it's cheaper to solve problems outside of your jurisdiction. And lastly, there should be ongoing education, and because you're trying to get an awful lot of people to change their practices. And with that, let me turn it back to Master Control.
Thanks, Jim. Okay, we'll be passing things over to Becky Pearson, who will be talking about breaking down the silos with respect to integrated water management. Becky, the floor is yours.
Okay, thank you. Let me show my presentation here. So I'm going to had the last slide open, so here's a preview of my presentation. Okay, breaking down the silos. This is a tool that is right now in the middle of development, but I'm giving you an overview of what this tool is and some concepts behind it. And basically, we used the experience that we had at a workshop earlier this year to help develop this guide. And what we wanted to do is have this guide help municipalities get in front of their next water crisis, because we all know that nobody really wants to talk to each other within a municipality. We all have our separate mandates. But if there's a crisis, that's when folks tend to talk. So we all have, we know that some crises that have happened in the recent past. This is the Toledo 2014 water crisis, where residents and businesses were out of water for 2 days. And this is a picture of a major artery which was flooded in 2008 that stopped traffic going both ways. Actually, I personally was stuck in this, and I couldn't get back to my home state in Michigan. And these crises, one of the factors that we're trying to address with the guide is that many of these have been a factor to these crises is that departments don't talk to each other. Roads get built without considering some of the flooding issues that might happen, or considering that storm events might be greater than past events, or will consider climate change in the mix. So the problem is, as I stated, are the silos. Here's a picture that I got from the internet that shows the silos.
Hey, Becky, this is Laura. I'm going to pause you for just 1 second. Your slides aren't quite fitting into the screen, so maybe if you just go back to exit out of presentation mode for a second and just restart it, you'll be at the right size there.
Did that work?
Yep, now we can see the slide. Let's see, it's still zoomed in a little more than we need it to be.
I'll go to the next one. Is that better?
The slide itself gets cut off once it goes into presentation mode. So let's see here. Yep, it's still getting cut off.
So I just expand it and deal with it.
That's just fine.
Work?
Yeah. Yep.
Okay, so here's a definition of integrated water management that we used for our workshop in Guelph. And it puts some words behind the graphics that you saw in John's and Jim's presentation. This working definition came from Ontario, and in general, IWM is about managing human activities and natural resources in a defined watershed boundary. So one step towards breaking down those silos is to get the right people talking. In Guelph, we asked folks from multiple departments within the city: transportation, finance, parks and rec, water. I'm sure I'm missing a few, but they were all there, and they were able to reflect on what IWM is for them and begin to have that discussion. So again, we had this experience for a workshop in early 2000. It was in 2005. This was a little bit of a typo. We had 30 or 40 people attend, and some of them came from the surrounding communities in Guelph. And that was particularly helpful because they shared their experiences with working in the municipalities. Here's another slide from the workshop showing that we invited experts to showcase certain elements of IWM on the ground working in Ontario in this case. And this is one of our project advisors, Christine Zimmer, from the Credit Valley Conservation Authority, discussing a case study of IWM at the workshop, which helped prompted discussions among the municipal department representatives at that workshop. We did a pre and post workshop survey, and we collected comments from the attendees about how this workshop went. Did they learn something? Was it of value? And we got a lot of positive responses, and this is just a few of them. And new ideas for implementing IWM came out of the workshop. So I'm going to briefly present the outline of this guide, which will come out later this fall. The guide will help present ways and suggestions of how to begin the discussion of IWM in municipalities. So part of it would include identifying champions within the various municipal departments that would help lead this workshop and the activities that come out of it, and provide suggestions on how to set the agenda, what that would look like, bringing resources together to make it happen, and getting the right people at the table at the workshop, and then continuing that dialogue that was started or prompted by the workshop into activities and additional discussions after the workshop. And of course, the guide will present some references and resources for further research. So here's more details on what an agenda should look like for a workshop that breaks down the silos. One of them is to present those real-life case studies of IWM. And it brings fodder for discussion at the workshop. Getting those experts to speak really is very helpful. And they also provide their own insight on some of the issues that are brought up in the facilitated dialogue. And related to that dialogue, you need a really good facilitator that can help lead those discussions and bring people in who don't really speak up too often into those discussions as well. And then, of course, block out plenty of time for that discussion. And then identifying the actions and opportunities to implement IWM. Okay, I'm going to wrap up the products coming out. So as you saw here today, we have a water resource impact tool and our silos guide that that you heard of. And those two products will be on our website coming this fall. You will be receiving an email once they're up and available. And you can go to the project website, which is listed here on this slide. And not only do we're going to have these tools, but we also have additional resources, fact sheets that really tell the story of some of the communities that we've been working with on these ideas, and some additional numbers behind the benefits that would incur should they implement some of the more progressive water management programs and projects. And then we also have some videos and media stories that really inspire folks in thinking more and reflecting on how water management should be looked at in terms of restoring the Great Lakes water cycle. So I'll end it there, and Melissa?
Great. Thank you, Becky. Okay, well, at this point, we are going to open the floor for any questions that folks might have. Again, feel free to type your question in your chat box. That'll go straight to Laura, and she can read them off. Or you're welcome to raise your hand and ask your question directly to the presenters. Laura, I'll turn to you and see first if there's anything from the chat box.
Yes, excuse me, we do have one question. This was from earlier during John Jackson's presentation, wondering about the conservation of drinking water and its effect on wastewater chemistry. So here's the question. The conservation of drinking water has affected wastewater chemistry, resulting in growing alkalinity deficits to support nitrification. Wondering if this effect was anticipated or considered in these processes.
I'm not the expert on the water use bill from the Alliance for Water Efficiency is, so I must admit I was not aware of this. I'm glad you've raised it, and I certainly will pursue it. Jim, do you know anything about this?
I know enough to be dangerous, and I would ask him to clarify the question. Well, I would love to answer that, and if he sends an email, we will give you a technical answer to that. But I'm a little. I'd rather give you a right answer than a quick answer.
Okay. And what we could do also, we will have the emails for others on the call, so we can send out the answer to everybody, so that all of you will be aware of what answer we have.
Great. At this point, we're waiting for some more questions to come in through the chat, so feel free to type them in or click the raise hand button if you'd like to speak over the phone. That's easy for us to make happen too.
I guess not hearing or seeing any questions at this point. Laura, do you want to just jump to the polling, and then certainly we can come back to questions if folks have generated some by that time.
Sure, sounds great. So we do have 3 quick polling questions that will show up on your screen in just a minute, and there will be a way for you to respond. So here is the first question.
And Laura, how do we respond to this?
There should be a button on your screen that shows up indicating your response. All right, I'm going to close this question. Thanks, everybody. Here's our second question. Has this webinar changed your view of water management? Great, thanks everybody. And we have one more question. After this webinar, I would like to go to the project website to learn more, use project resources to influence action in my community, pass this information on to my colleagues, all of the above or none of the above. Okay, a few more seconds to get some votes in. Okay, I'll close this poll now. And that was the final question on there.
Great. I guess we'll put out one more request. Any questions that folks might have for the presenters?
I do have, let's see, I have a couple questions that came in. One, if you're just wondering if you'll be able to access this webinar in the future, the answer is yes. It will be, a recording will be posted on the Cities Initiative website, as well as PDF files of all the presentations, and we'll let everyone know when those are available. I also have a comment here from Sandra Cook saying, I challenge the speakers to broaden your scope and integrate rural stormwater. Many cities live downstream of rural areas. Improving rural runoff will assist with assimilative capacity, reduce treatment costs for drinking water, et cetera, et cetera.
Great. And just back on the webinar, we'll, Becky and John, somehow link the archived webinar to the website that is listed up on the screen right now, the glc.org website for the Greater Lakes Project. So folks can just make one stop.
Yep. We will do that.
Great. Well, I wanted to just thank everyone again for joining us. Again, we'll be sending out an email as these tools are available on the listed website. And we will follow up on that one question regarding the water quality so that we get Bill Christensen of the Alliance for Water Efficiency to weigh in on that. Thanks again for joining us on the last of our Integrated Water Management webinar series, and have a great day, everyone. Thank you.